Alright, now we're going to continue with the review sheet, number 68. It says an unbalanced force of 10 newtons acts on a 20 kilogram mass for 5 seconds. The acceleration of the mass is, so this is just Newton's second law. F is equal to ma, and we want to find A. This is, again, the net force. So A is equal to F net over m. They gave us the net force, because it's unbalanced, divided by the mass, which is 20 kilograms. So 10 divided by 20 is 0.5. A newton is a kilogram meter per second squared divided by a kilogram. These cancel, and I get the correct units, meters per second squared. Did I need to know the time? No. So this is, again, number one, you need to be able to say, did I need this information in the problem? Because in this case, this wasn't necessary to solve the problem. So the answer here was A. Number 69. The diagram below shows a horizontal 8 Newton force applied to a 4 kilogram block on a frictionless table. What is the magnitude of the block's acceleration? So again, we're applying a Newton's second law. F net is equal to ma. A is equal to F net over m. So it's equal to 8 newtons over 4 kilograms, and 8 divided by 4 is 2. Now, a lot of you would just do this in your head. When you do things in your head, that's how you make a mistake. So when you write down your equation, number one, you rearrange the equation to solve for the unknown in terms of the known. So the answer here is 2 meters per second squared. Now, what if I tried to do it in my head, and instead of doing 8 divided by 4, I did 4 divided by 8? Because that's a common mistake people would make. Is that one of the choices? Yes. What if I said, well, maybe it's multiplication. What's 8 times 4? Is that one of the choices? Yes. So do you see how the most common mistakes people make, those are the choices? And if you make that mistake, you're going to be like, oh, yeah, there's my answer, and you're going to move on. The more you write down on paper, the less likely you are to make a mistake. All right, number 70. It says a baseball bat moving at a high velocity strikes a feather. If air resistance is neglected, compared to the force exerted by the bat on the feather, the force exerted by the feather on the bat will be. So this has to do with Newton's third law. For every action, there's an equal and opposite reaction. So this is going to be the same. Now, how long would this take to do this question on the exam? As long as it takes to read it. So would you say this is one of those like 5 to 10 second questions? So we want to make sure these easy questions, we don't get these wrong. Number 71, a ball having a mass is struck by a bat having the mass of 9m. So the bat's mass is 9 times its grade. Compared to the magnitude of the force exerted by the bat on the ball, the magnitude of the force exerted by the ball on the bat is the same. Newton's third law. Okay, number 72. It says the weight of a 2 kilogram mass on the planet A is 40 newtons. So I know that the weight, F of g, is equal to mg, and that's equal to 40 newtons. The acceleration due to gravity is, well, they also tell me that the mass is equal to 2 kilograms. So F of g is equal to mg. So little g is equal to F of g over m. So it's 40 newtons, which is a kilogram meter per second squared, divided by the mass, which is 2. Now 40 divided by 2 is 20. And then my kilograms cancel, and I end up with meters per second squared for my acceleration due to gravity, which is choice A. Now, if I try to do this algebra in my head, that's why in physics it's so great that you have a foolproof way to check your algebra every time. You carry your units through and cancel them, and it checks your work, and then I got my correct unit with meters per second squared. And if we look at the wrong answers, if I, instead of doing 40 divided by 2, if I did 40 times 2, is that a choice? They don't have the 2 divided by 40 choice, but they have the most common incorrect answers that people would do. All right, number 73. It says the graph below shows the weight of 3 objects on planet X as a function of their mass. The acceleration due to gravity is, so if I look at the graph, this is the weight, F of g, and this is the mass. So I know that F of g is equal to mg, and I want to find little g, so little g is equal to F of g over m. So I'm going to look at the graph. I always like to pick the endpoint. It really doesn't matter, but on this graph, I want to pick points that are easy to read. So I'm going to pick this point and this point. Why did I pick this point? Because it's right like on an intersection, so I don't have to like interpolate between the lines and try and figure out what it is. So this slope is actually little g. So I'm going to do the weight, which is up here, which is 300 newtons minus 0, over the mass, which I'm going to come down here, which is 50 newtons minus 0. So 300 divided by 50, I can do in my head is 6. And if I carry my units through, this is kilograms. I have a meter, a kilogram meter per second squared divided by a kilogram, and I end up with meters per second squared, which is the correct unit for acceleration. Number 7, there's no calculation. The diagram below represents a box shown sliding down an inclined plane. Toward which point would the force of friction? So first of all, the box is this is the way it's moving. So what do we know about the force of friction? We know, number 1, the force of friction acts opposite motion. Then we also know that friction acts parallel to the surfaces in contact. So I can eliminate choice 3 because that's the direction it's moving, and I can eliminate 1 and 4 because they're going perpendicular. So the choice is choice 2. All right, next page. Okay, it says a book weighing 20 newtons slides at a constant velocity down a ramp inclined 30 degrees to the horizontal as shown. What is the force of friction? So we know the force of friction is going to be opposite. It's going to be going up. So I can either read my choices or right off I can say, well, I know these two are wrong because those say down and friction is going to be going up. It says, what is the force of friction between the book and the ramp? Now, if I drew a free body diagram for my book, remember my weight goes down, my frictional force goes opposite the motion, and my normal force acts perpendicular to the surfaces in contact. But when I sum my forces, everything has to be going perpendicular and parallel to the surfaces in contact. So I would have to break my weight up into my components. This is Fg, and then I would have Fgy and Fgx. And this angle here is 30. When I look at my free body diagram, I see that my frictional force is going to be equal and opposite because it's moving at a constant speed. My frictional force is going to be opposite Fgx. So I can just say that Fgx, which is f of f, is going to be f of g times the sine of 30 degrees. So it's going to be the weight, which is 20 newtons, times the sine of 30 degrees. So you see how this one might take a little bit longer for you to calculate? And again, it's sine because the x component is opposite the given angle. Okay? So I do that on my calculator, and I end up getting 10 newtons up the ramp. Now, if I did cosine instead of sine, is that one of the answers? Yes. So this one might take a little bit longer to calculate. So on your first pass, I would do this on a second pass. I'd say, I'm going to have to draw a free body diagram. I'm going to have to, use my calculator. I might save that for my second pass. Okay. Okay, number 76. Which pair of concurrent forces? So what is a concurrent force? Concurrent means acting at the same point at the same time. So which pair of concurrent forces may have a resultant of 20? Well, when I add numbers algebraically, I can just add them. When I add vectors, the one rule for adding vectors is adding them head to tail. So when it says which would be a possible resultant, well, if I found the maximum and the minimum of each of these forces, I would have an infinite number of resultants in between the maximum and the minimum. So what I'm going to do for all of these is I actually have to look at all the choices and find the maximum and the minimum. So the maximum is when I add them together, and the minimum is when I subtract them. And then, again, I can have an infinite number in between the maximum and the minimum. So let's start with the first one. When I subtract them, 10 minus 5 is 5, and then 10 plus 5 is 15. So I can have an infinite number of resultants in between 5 and 15. Is 20 in between 5 and 15? No, so that answer's not correct. So the next one, 20 and 20. So 20 minus 20 is 0. 20 plus 20 is 40. Is 20 in between 0 and 40? So that's actually my correct answer, B. But let's just go on. So here, 50 minus 20 is 30, and then 50 plus 20 is 70. So 20 is not in between 30 and 70. And then the last one, 30 minus 5 is 25, and 30 plus 5 is 35. So again, 20 is not between 25 and 35. So if you're not sure because you found the answer was B and you just want to keep going, just go ahead and do the rest. Number 77. The diagram at right represents two concurrent forces acting on a point. Which vector represents the resultant? So remember, with vectors, you cannot add vectors algebraically. You have to add vectors vectorially. The one rule for adding vectors is you add vectors head to tail. So here's my two vectors. Does it matter which one I do? It doesn't matter. If I do the top one like this, from the head of this vector, I do the tail of the other. There's my resultant. So now when I look at my choices, the one that looks like that is obviously D. But what if I didn't do that? Can I do it the other way? Sure I can. So I can start with the other vector here. And then from the head of that vector, I do the tail of the other. Does my resultant look the same? Yeah. So it doesn't matter if I do A plus B or B plus A, as long as I add my vectors head to tail. And again, from where I start to where I end up is going to show me the direction of my resultant. This is where I start, this is where I end, this is where I start, and this is where I ended. Okay. Number 78. It says a red ball and a green ball are simultaneously thrown horizontally from the same height. The red ball has an initial speed of 40 meters per second, and the green ball has an initial speed of 20. Compared to the time it takes the red ball to reach the ground, the time it takes the green ball. Now, just from doing this, you should know that they're going to hit the ground at the same time, but let's say you forgot that. If I drew a picture of it and I have a ball like this, and it's thrown horizontally, it's this type of projectile. With this type of projectile, remember when I write my givens, I separate my x and my y givens. I know that there's never any horizontal acceleration, and the vertical is 9.8 meters per second squared. If this is my initial velocity, it's all horizontal. It has no vertical component. So Vix is equal to Vi, and Viy is equal to 0. And then I have my height, y. Well, these two y's are the same. So if I looked at it solving for this, and I use my equation y is equal to Viyt plus 1/2 gt squared, there's no vertical component of the initial velocity. So y is equal to 1/2 gt squared. If I wanted to solve for the time it takes to reach the bottom, if I rearrange this equation, multiply both sides by 2, divide by g, take the square root of both sides, t is equal to 2y over g. So the only thing that makes a difference when I throw a ball horizontally and how long it takes to hit the ground, the time, is going to be how high it is. And because they both are at the same height, it doesn't matter the horizontal speed because the time is going to be the same. So the answer there is going to be A. Okay, number 79. It says a ball is thrown horizontally at a speed of 20 meters per second. from the top of a cliff. How long does the ball take to fall 19.6 meters? So they gave me y. Again, that's negative because I'm measuring from here down. And I already did the calculations here, so we just use that same equation. Remember, y is equal to VIYT plus 1/2 GT squared. This is 0, so y is 1/2 GT squared. We rearrange the equation to solve for the unknown in terms of the known, so t is equal to the square root of 2y over g. We substitute in our values. 2 times negative 19.6 meters divided by negative 9.8 meters per second squared. If we're consistent with our sign convention, and remember, we're always going to use the standard Cartesian sign convention, up and to the right is positive. So from where motion begins here, this was negative. G pulls down, that's negative. So the negative in the numerator cancels with the negative in the denominator, and then I don't have a negative under the radical. And when I do the math, it comes out to be 4 seconds. If I forget to take the square root, they don't have that as a choice. Usually they have one of the wrong answers if you forget to take the square root. All right, number 80. A ball is thrown horizontally from the top of the building with an initial velocity of 15 meters per second. At the same instant, a second ball is dropped from the building. And the question is that the two balls will have the same, they don't have the same path because one drops straight and one goes like this. The final velocity, this one is going to be at an angle like this. The initial horizontal velocity, well, this one starts from 0, this one's thrown, but the vertical velocity for both of them is going to be what? VIY is 0. So that's the choice D.
It says that, like, for number 79, that when you square root it, it gets 2 instead of 4. Because it's 2 times 19.6, like 39, and then divided by 9.84, and then square root of 4 is 2.
Oh, I circled the wrong choice. Thank you. The answer is B. And I circled D.
Yeah, they get the headline like that, too.
So this one is 2. Okay. So you don't want to forget to take the square root. Thank you. All right, number 81. An object is thrown in the air and follows the path shown in the diagram above. Which vector represents the acceleration in the point? Well, when something's traveling through the air, what's the only acceleration acting on it? The acceleration due to gravity. So the acceleration due to gravity of point A goes down. So the choice is C. What if I asked you here, the acceleration always is going to be the same thing. It's going to be the acceleration due to gravity, and it's always going to be pointing straight down. Next page. We all make mistakes. The first time I did this, I make mistakes. Well, that one I wrote the right answer, but a lot of times I might forget to take a square root. I might forget to do something. And especially with some of these problems, they're simple, but we all make little mistakes. And that's why you want to also check the math in your head, because you can press the wrong button on the calculator or forget to press a button. All right, number 82. A projectile is fired at an angle of 53 degrees to the horizontal with a speed of 80. What is the vertical component? What I would do is I would draw a picture. So this velocity is 80 meters per second, and it says and the angle is 53, and they want to find the vertical component. So this is the vertical component. The vertical component is opposite the given angle. So if you're not sure, sine, cosine, tangent, write out your definitions. Sine of theta is opposite over hypotenuse. Sine of 53 degrees is equal to opposite, the vertical component, over the hypotenuse of 80. So V sub V is equal to 80 times the sine of 53 degrees. So that comes out to be choice C. Number 83. An archer uses a bow to fire two similar arrows with the same string force. One arrow is fired at 60 degrees with the horizontal, and the other is fired at an angle of 45 with the horizontal. Compared to the arrow fired at 60, the arrow fired at 45. The first thing I would say is, one of the things we already did and we calculated is, which one is going to go the farthest? 45 degrees. So let me see. So compared to the arrow fired at 60, the one at 45 is going to have a longer horizontal range, right? So I'm going to eliminate this and eliminate this. And then, so first of all, and then I start looking at the other choices as far as the flight time. So remember we looked at the ones that were complementary to each other? So this one's going to have the longer horizontal range, but it's going to have the shortest flight time. So the answer is C. Now, we could work that out mathematically, but wouldn't that take too long to work that out? Like to work out X and T for 45 and 60. That would take too long, right? So that's why for a question like that, you don't want to work it out. Number 84, the average speed of a runner in a 400-meter race, so X is equal to 400 meters, is 8 meters per second. How long did it take the runner to complete the race? So V is equal to X over T. So T is equal to X over V. So it's 400 meters divided by 8 meters per second. So 400 divided by 8 is 50. And then a meter divided by a meter per second is 1 over a second, which is a second. So the answer comes out to be 50, which is choice B. Number 85, a cart starting from rest. So travels a distance of 3.6 meters in 1.8 seconds. The average speed is, so V is equal to X over T. So it's the same thing. T is equal to X over V. So it's 3.6 meters. Oh, we want to find V. Whoops. So this is V is X over T. So it's 3.6 meters over 1.8 seconds. So it just comes out to be 2 meters per second. We did that in middle school. All right, number 86. An object with an initial speed of 4 meters per second. Now this one is going to accelerate. So I'm going to have to use my equations with, I'm so lucky I don't have to have them memorized because we have them all on our equation sheet that we're going to use for a semester exam. So I'm going to write down what I have because it's going to help me to figure out which equation to use. So VI is equal to 4. And we're going to chunk the problems. It accelerates uniformly at 2 meters per second squared in the direction of motion for a distance of 5 meters. What is the final speed? So I want to find an equation that has VI, A, X, and VF. So that equation is going to be VF squared is equal to VI squared plus 2AX. VF is equal to the square root of VF squared plus 2AX. So now I'm going to substitute in my values. So it's going to be 4 squared plus 2 times 2 times 5. And you know, I can do this in my head. 4 squared is 16. 5 times 2 is 10 times 2 is 20. The square root of 36, I can do that in my head too, so VF comes out to be 6. Now you could still do it on your calculator, but the point is most of these numbers are so easy that you can do them in your head that you should just check it mentally. You know, visualize and say, did I remember to press that square root button at the end? So this comes out to be 6, choice A. Okay, number 87. It says a car having an initial speed of 16 meters per second, so VI is 16, is brought to a rest, so VF is equal to 0, it's brought to rest. How far does it travel during this 4-second interval? So T is equal to 4 seconds, and I want to find X. So my equation that has those variables is X is equal to VI plus VF over 2 times T. So X is equal to 16 plus 0 over 2 times 4. So 16 divided by 2 is 8 times 4 is 32. If I want, I should carry my units through and cancel them. So in the numerator, I have meters per second times 4 is a second, and this second cancels with that, and I end up with meters, which is the correct unit for displacement. Number 88, an object originally at rest, so that means VI is 0, is accelerated along a straight line path to a speed of 8 meters per second, so that's VF is equal to 8 meters per second in 2 seconds, so time is equal to 2 seconds. What is the acceleration of the object? So I have VI, I have VF, I have T, and I want to find A. So now I'm going to say which equation has those 4 variables. That's the one that says VF is equal to VI plus AT. I'm going to rearrange the equation to solve for the unknown in terms of the known. So VF minus VI over T is equal to A. So it's 8 meters per second minus 0 over 2 seconds. So 8 divided by 2 is 4. And a meter per second divided by a second is going to be a meter per second squared, which is the correct unit for acceleration. So my final answer ends up being 4, which is choice D. And if you forget to take the square, oh, this one you don't have the square root. So if you did 8 times 2, if you made an algebra mistake, is that a choice? Yeah. Number 89, a car having an initial velocity of 12 meters per second slows uniformly to 2 meters per second in 4 seconds. What is the acceleration? So I'm going to use the same equation. VF is equal to VI plus AT. So A is equal to VF minus VI over T. So it's going to be 2 meters per second minus 12 meters per second divided by 4 seconds. So 2 minus 12, this gives me a negative value, right? So this is negative 10 over 4. Well, 10 divided by 4 is 2.5, but it's negative 2.5. So the negative sign tells me it's going in the opposite direction that I'm calling positive. So normally with my standard sign convention, east and north are positive, and west and south are negative. So because I get a negative 2.5 meters per second squared, my answer is going to be west, which is going to be choice A. Number 90. Which is constant for a freely falling object? Well, that's the acceleration due to gravity, so that's D. So that's one that's going to take you about 5 seconds. Do you see how this is the end of the test? So that's why you want to do your 3-pass system, because you're going to answer that on the first pass. Number 91, a rock falls freely from rest, so that means that VI is 0. Near the surface of a planet where the acceleration due to gravity is 4 meters per second squared. What is the speed of the rock? So I want to find VF after it falls 32 meters. So I have VI, I have G, I have Y, and I want to find VF. So which equation has those variables? So it's the equation VF squared is equal to VI squared plus 2GY. VI is 0, so VF squared is equal to 2GY, and I want to solve for VF. So VF is equal to the square root of that, so it's the square root of 2 times negative 4 meters per second squared times negative 32. So why was this negative and this negative? Because remember, it's falling down. This is where motion begins. My standard Cartesian sign convention says up and to the right is positive. So VF comes out to be 16 meters per second, which is choice B. Number 92, a ball dropped from a bridge takes 3 seconds, so it's dropped, so I know the initial velocity is 0. It takes 3 seconds, so that's the time. How far is the bridge from the water? So I want to find Y, and the only thing I'm missing here, when something's falling, the acceleration acting on it is the acceleration due to gravity, negative 9.8 meters per second squared. So Y is equal to VIT plus 1/2 GT squared. This goes to 0. So Y is 1/2 GT squared. So Y is equal to 1/2 negative 9.8 meters per second squared times 3 seconds squared. So Y came out to be 44. Why is it negative? Because when I drop something, I'm measuring from here down. So because Y is pointing down, it should be negative. So this is 44 meters. So the answer is C. Number 93, which graph represents an object moving at a constant speed? So on a position versus time graph, the slope of the line represents the speed. So a constant speed, this is a zero slope. This is a changing slope, and this one starts off and then changes. So the answer would be this one, D. So I need to know on a position versus time graph, the slope is going to be the velocity. On a velocity versus time graph, the slope is the acceleration. And on a velocity versus time graph, the area under the curve is the displacement. Which pair of graphs represents the same motion? So now I know what the distance versus time... Oh, so I want to see which out of these two represent the same thing. So this one represents a constant velocity, and that represents a constant velocity. So these two match up. So the answer is A. Now, I could go on and look at the rest. If I'm not sure and I want to check, this one starts off with... This is quadrant 1. This is a negative velocity, and this doesn't show this starting off at negative. So these don't match. This one is standing still, and these graphs can't be the same because then on position versus time and velocity versus time, oops, we can't have the same thing. Okay. So if you just want to go on to make sure that was the right answer and read the other choices, go ahead. Again, these are questions that you should be doing on a first pass because they're only going to take about 15 or 20 seconds. All right, now we're going to look at this one. It says, base your answers to the following questions on the 4 graphs below, which represent the relationship between the speed and time. What object traveled the greatest distance? So the distance on the speed versus time graph is the area under the curve. I don't really think, me personally, I can tell by looking at the graph. So I would actually calculate it. So I'm going to have to find the area under this curve, the area under this curve, this area, and then this area. Well, you can see this area is bigger than that, which is bigger than that. So you probably can do it by looking at it, but I would still probably calculate it. So this one is 1/2 base times height. So it's going to be 1/2, the base is 3, times the height is 30. So 30 times 3 is 90 divided by 2, so this one's 45. This one is just base times height, so it's going to be 3 times 20 is 60. This one I would break up into 2 shapes. So I'm going to do the rectangle and the triangle, which is the same as that one, which is 60, plus this little triangle here, which is 1/2 base times height. So it's 1/2 of 3 times 10, so 30 times this. So I add these together, this comes out to be 75. And then this one I would also break up into 2 shapes, and I would do this rectangle, base times height, plus this little triangle, which is 1/2 base times height. So it would be 10 times 3 for this one, plus 1/2 of 20 times 3. So it would be 30 plus 30. So this one is 60. So this is the correct answer here. So sometimes you can tell by looking. Sometimes it might be kind of close. So you can always calculate it. All right, the next one says the graph below shows the speeds as a function of time for 4 cars, A, B, C, D, in straight line motion. Which graph experienced the greatest average acceleration? So the acceleration is the slope. So the one that looks like it has the average of this, it's going to be the steepest slope. So that's going to be this one. So the answer is going to be D. So that one should just take a couple of seconds. Number 97, which is a derived unit? So this is a standard unit, a standard unit, a standard unit. So it's a Newton. Which is most likely to have a mass of a high school student? All year long we've been doing labs. You've been massing stuff on the triple beam balance. As a matter of fact, you figured out your mass when you weighed yourself when we did the power lab. So you should know that this would be about the mass of a student. Kind of a little. And when we had our question, our last FRQ test, and you figured out Miss Diversa's mass, remember Miss Diversa came out to be about 60 kilograms in that problem? Okay. Last page, which are the last easiest questions on the test. The height of an average adult, we've been using meter sticks all year long, so you should know that meter sticks, a person's usually taller than a meter stick, so it's about 1.75 meters, not centimeters, not millimeters, and not kilometers. And then the last question is, which term represents a fundamental unit? And again, a meter is a fundamental unit. And that's it. That's our 100 questions on our review sheet, very similar to our 100 questions on our test. And that's it.